Welcome everyone for UIC-CME new graduate student orientation. So my name is Krishna Reddy. I'm a professor of civil and environmental engineering. So you have my email address right there. So if you are interested in contacting me, that's the email address. So my area of expertise is geotechnical and geoenvironmental engineering. So I'm going to give you a brief overview of graduate study opportunities in this field. Okay. So what I will do is give you a little bit of background before I talk about my research. So, many of you are civil engineers. So civil engineers design, build, and maintain the foundation in our modern society. You cannot imagine society without civil engineers. And we, civil engineers build buildings, roads, all kinds of infrastructure, right? And then in addition to fundamental civil engineering background, the civil engineers specialize in one of the areas. So these areas, you specialize via practice. Somebody may be working in a field for many years, they become experts, or you get an advanced degree like, masters and PhD that you're getting. So these specializations are environmental engineering, kind of a name says it all. Geotechnical engineering, I don't know, not many people understand what this term stands for. Structural engineering, you probably know already based on the name itself. Transportation is very clear. Water resources is very clear. And there are other disciplines within civil engineering, but these are the most common ones. So the geotechnical engineer, and the term itself is not as easily understood as other fields, structures, environmental, and everything. So this is a bit challenge, and nowadays people use, instead of geotechnical engineering, geotechnics. That makes it even worse, for ordinary people to understand what this field is all about. So I just want to, you may have the idea what this one is all about, but generally geotechnical engineers do these subsurface investigations. Anytime you want to have a project, you need to know what kind of soils that you have at the site. And every civil engineering structure needs the foundation. Geotechnical engineers should design the foundations and design the earthworks like dams, levees, and tunnels, underground structures. And they also investigate the land mass problems such as landslides, slope stability, subsidence. These are very, very important subjects to address for infrastructure development. Without these topics or without the expertise of a geotechnical engineer, you will not have infrastructure. So, but what is happening? We have been thinking about build, right? So with that, what is happening is we are not paying attention to a lot of environmental damage that we are causing as a result of building infrastructure. If you look at this graph, okay, so the horizontal axis is Human Development Index. When you have more than 0.8, it's a developed country. And then, if you look at this dashed line, that is the, amount of environmental abuse that planet can take. They can recover easily. But ideally, you want to be a developed country, and you want to be within the means of the biosphere, right? That's a sustainability quadrant is the one that you want to be in there. You look at it, these are all the different countries, none of them are in that sustainability quadrant. That means nobody is want to be a developed country, at the same time keep the resources under the biocapacity of the planet. So look at the US. US is a very well-developed country, but look at how much ecological damage that we have caused. And a lot of these developed countries are the same thing. They developed at the cost of ecological damage. A lot of these developing countries, including China, India, and all those countries, they're trying to follow these developed countries. That's a really bad sign. We should be going horizontally into this sustainability quadrant. That is the ideal thing. So this, you're talking about the ecological damage, right? But in addition to that, we are depleting a lot of natural resources. Building construction materials, you need all the materials. We're running out of those materials, and we're creating a lot of waste. We're creating a lot of waste, and that we are having a lot of issues with handling the waste. And we are increasing the pollution. Soil is polluted, water is polluted, air is polluted, and we are increasing the greenhouse gas emissions. And as a result, we are causing climate change. You hear every day on the news that there are some extreme climate impacts happening. So, and also, we are not worried about the sustainability, like a long term, how can we maintain the sustainable development, right? So these are big challenges. So I just wanted to give these ideas because, no matter what you're pursuing, you need to look at this big picture in mind. So we have challenges to address. So how could we address these challenges? So one of the fields that can address some of these challenges is called geoenvironmental engineering. So geoenvironmental engineering is a combination of geotechnical engineering, that as I mentioned before, what they do, more mechanical and hydraulics. And environmental engineers, generally they deal with water, wastewater, and air. So they don't deal with the soil, they don't deal with the groundwater, they don't deal with the waste management, landfill design, waste containment, other things. So this is the combination of these two fields that is essential to solve these waste management problems and contamination problems. So a lot of people, are not very comfortable, trying to study two subjects together. So they are comfortable studying one or the other. So in fact, it's a little bit even broader. With these environmental issues, you need to take a little bit of bigger picture, not only environmental and geotechnical, but you need to look at the geochemistry, microbiology, a lot of economic issues, laws and regulations. So all these things have to be looked into in order to come up with a holistic, perfect solution to the problem. So this is the book that I wrote many years ago that basically tells you the scope and the importance of this subject. So having this background, you can actually solve all these non-hazardous, hazardous waste problems that we have currently and we expect to have as we go into the future. And also contaminated sites. There are many contaminated sites. If you look at the US EPA news briefs, there are many, many contaminated sites that needs to be cleaned up because they're posing a lot of problems to the humans and getting all kinds of diseases, that you cannot explain otherwise. And also there's a need for going into the future sustainable development, right, and climate change impacts. So we need to look at renewable energy sources like geothermal or biogas, or you need to look at carbon sequestration methods because CO2 is very high. How can we sequester that one? And also the resiliency, basically you're mostly looking at nature-based solutions. So there are a lot of innovations to pursue to address this problem going into the future. So we need to address the problems that we caused and we expect to have. At the same time, we need to be proactive to address the problems, prevent the problems from happening in the beginning. The other thing that I want to mention, this is, I focus mostly on geotechnical and geoenvironmental issues, but this is the sustainability and resiliency is the hard topics, and these should be considered in everything that you are looking at it. So when I look at the solutions to geotechnical and geoenvironmental problems, I look at the sustainability and resiliency. I strongly advise you to look at these two aspects, in anything that you do, structures or environmental, water resources, and things. So you need to look at the life cycle, from the beginning, acquisition of the materials, manufacture of the materials, transportation of the materials, building it, maintaining it, and then at the end, disposal. So that's called life cycle. Civil engineers never think about that thing. And the triple bottom line is the functional definition of sustainability. You need to look at broader environmental impacts, broader economic impacts, broader social impacts, how it's going to deal with, how it is going to influence people. That's extremely important. So you need to consider triple bottom line. And then on the climatic point of view, there are a lot of climate impacts are happening. The way we have been designing, they don't work. You don't want them to collapse. There may be some, compromising in terms of the performance, but they should be able to recover. So this is called, resiliency. And then basically we need to achieve both sustainability and resiliency. So I have a book on this one. Basically, if you want to understand these concepts, you get hold of this book and read it. It's freely downloadable from our library. And then basically what I want to do is anything that I do, I quantify the sustainability and resiliency, see whatever the solution that I'm coming up with is truly sustainable or truly resilient. Because this quantitative framework is extremely important to do this one. So I teach a course on sustainable engineering at a graduate level, 514. A lot of students take it and a lot of students do their own projects and they quantify the sustainability and project that they have. So these are the courses that we teach, geotechnical engineering courses and the geoenvironmental engineering courses. So geotechnical courses are mostly towards the infrastructure development and the geoenvironmental courses are more geared towards the environmental aspect. So having both of them, you can really develop environmentally friendly or sustainable infrastructure. And then of course, in addition to taking the courses, students do the research on the topic of their interest. So my research, a lot of students, research students who work with me, masters or PhD, they work on environmental remediation of soils, sediments, groundwater, and stormwater, not water or wastewater or air. So it's all dealing with the geo. and they all deal with waste management and landfill engineering. So again, the waste management is what we need to do. And then this life cycle assessment and sustainable and resilient engineering, as I mentioned in the previous slide. So there is a lot of scope for applying this quantitative framework to really see what you are doing is sustainable or resilient. Okay? So I developed the framework, and that framework can be used by anybody, but I apply to a lot of things that I am interested in, but the framework can be applied by anybody for any project. So my master's and PhD were in geotechnical engineering. As I said, I teach that subject, but most of my research is this. The first two is the geoenvironmental and sustainable engineering, sustainability and resilient engineering. That's the one. So a lot of my students work on research projects that involve lab testing and modeling and then field testing. So I'm not like just a modeler, I'm not just an experimentalist, I am an all-rounder. So I like to do, play with the experiments in the lab because they are really easy to do it, and then I am, translating those fundamentals into mathematical modeling is extremely important, and then mathematical model can be used to scale up your field system. So that's my goal is, to advance the fundamentals, but at the same time, I want to come up with a solution to the real-world problem. So this is my lab, and so just to give you an example, these are the types of thesis topics that people have worked in the last year. See, the first one is on landfills, second one is on the climate change impacts on levees, third one is again the stormwater pollution using the waste materials, and the last one is about addressing the landfill gas emissions. So this gives you an idea about the types of research projects that I do. And then, so far, 21 PhD students, 25 master students, 32 postdoc visiting scholars have worked in my lab. So these are the pictures of them. Everybody's smiling. So working in my lab is not a torture. It's a lot of fun. So I think most of them are laughing, right? So with their hard work, so we published a lot of these 4 books and a lot of papers. If you are interested, you can get that information. But most importantly for students, what is important is to get a job, right? So after you finish your degree, you want to get a job. So my students, when they finish graduation, so they are like a geoenvironmental, right? They have a geotechnical background and environmental background. So there is no geoenvironmental engineering job positions. So you have only these, right? Geotechnical and environmental engineers. So my students are working as a geotechnical engineers or environmental engineers for government agencies, private companies, some universities. So they are actually doing much better than I am in terms of the salary. So it's good though, that's okay, but the students are doing better than you, you are proud of it, right? So if you are interested in joining our lab, this is my email address, I'm connected on social media. And then mainly if you go to these websites, you can find more information about our projects. Thank you very much for the opportunity.